Okay. Well, we have this expression, we want to simplify it. First thing we do is we take the 375 and we do its prime factorization, so we know what numbers this thing's composed of, so we know what to do with it. So 375, well, we can divide it by 3. It's 3 here and 125 here. Then continue to write down the 3. Because 125 breaks down to 5 times 25. So now we see that 375 is 3 times 125. It is 3 times 5 times 25. And ultimately it's 3 times 5 times 5 times 5. Your prime factorization that is 3 times 5 cubed. As soon as you write it out that way, since you see what to do with the x and the y, everybody got that? We see that this is then cube root of 3 times 5 cubed times x to the 7th times y to the 12th. Include the multiplication signs. Since I need them, the numbers, I'll go ahead and to be consistent and include them on the symbols as well. It's not absolutely necessary in the symbols. It helps you see, hopefully helps you see what's going on. Okay, now the way I will do this, I'll say that's the cube root of then 3 times 5 cubed. Okay, now of course the cube root of 5 cubed is going to be 5, right? Times x to the 6, because the cube root of x to the 6 is x squared. Since you can group x to the 6 into 3 pairs of x's. X times x, x times x, x times x. X to the 6 is x cubed, x squared cubed. And then y to the 12th, because you can do the cube root of y to the 12th. Of course, you still have to write that x that you took away when you wrote x to the 6, right? So you have an x to the 7. So now everything but the 3 and the x is going to have the cube root. Now, just to emphasize all the rules. Okay, we got the cube of 5. We've got the cube of x squared. That's what your x to the 6 is. And we've got the cube of y to the 4th. We should be written a little higher. And squeeze it in. My 375. Well, you might not be able to read that 3, but you can tell what it is. Okay, you know what it is. Because y to the 4th cubed is y to the 12th. Right now, the extra steps that you really should understand. Okay, even though you went right to the heart of it and did the x to the 7th and y to the 12th correctly, and some cases almost did that 375 right, but you got 125 out here. Yeah, that's not what you get. So let's make sure we understand. Okay, so this is going to be, we could write this as the cube root of I don't need the multiplication signs here, just to say, yeah, but I do need an S. The 5, the x squared, and the y to the 4th can be all written together. the cube around the group. Because you're gonna have 5 cubed, you're gonna have x squared cubed, which is x to the 6th. And have y to the 4th cube, that's a y to the 4th cube, that's your y to the 12th. And then it's times the cube root of 3x. Now, we can write it out. As just plain old 5x squared y to the 4th. Because the cube root of a cube is just whatever's being cubed, right? And then that's times cube root of 3x. So just to see if we can really do this. Going to ask you to do one more, okay? You're in pretty good shape, and you don't know how to do all these steps. Well, let's see if you do all these steps, because that really brings it together. If you do all these steps, I'm pretty sure that you really understand it. I'm pretty sure that you pretty much understand it because you did pretty well with the example I gave you. So let's try cube root of 128. Let's do a fourth. We're going to do a fourth. Okay. Yeah, just 148. Right. Gonna do 4 through x to the 9th, y to the 19th. It's going to be 384. See if you can imitate all of these steps. Okay, first thing I want to do is I want to go ahead and do the prime factorization of 384. Then I'll do the rest of it on the new board. So let's just do 384 here. 384 is 2 times 192. 192 is 2 times 96. Now, if I multiply 2 times 192, I get 384. If I multiply 2 times 96, I don't get 384. Why not? Because I didn't write this 2 down. And now, if I multiply them out, I still get 384. Because I always want to be able to check that every row here multiplies out to my original number. Okay, well, it's a little tedious to write it out. That's part of life. 96 is 2 times 84. I've got to bring these 2's down. Okay, because again, if I multiply these out, 2 times 2 times 2 is 8. 8 times 48, you can verify is 384. Yeah. Right there. Okay. Okay. 44 cents of this side. There we go. 2, 2, 2, 2, 2. Still a nice process. You just break this down and then you can sure you write all the others down. Okay. You know, all these multiply out to 384. We're going to run out of 2s, let's say. Eventually we're going to, because this process has to end somewhere. And we know we don't have an infinite number of 2's sitting there hiding inside of 384. Okay. So we got 12. Now we got 2 times 6, 2, and 2, 2, 2, 2. I've got to write small, so I'm almost out of room, but I'm almost there because now when I divide 6, I'm going to get 2 times 3. And yeah, I can't divide 2 by anything, can't divide 3 by, but not by any integer other than 1. Okay. In other words, this is not going to break down because I can't break down to 2 or 3. Break down to 6, I break down to 96, but I'm finally down to something that won't break down. So now, prime factorization. And you know, I'll bet I'm almost off the board, almost off the camera. Not quite. Make sure. Okay. Prime factorization. Okay. Factorization. Okay. Prime factorization is what? 1, 2, 3, 4, 5, 6, 7 twos, 2 to the 7 times 3. Okay, so now we know that this is the 4th root of 2 to the 7th times 3 times x to the 9th times y to the 19th. Okay. Now I don't have room to continue this, so we'll just that thing's not quite right, but I think I can write on it. Okay, so let's just write again. So I have now the 4th root of this. Okay. Now, I can think of taking that x to the 9th and writing it out as a product of 9 x's. I do the same thing with y to the 19th, but I don't want to write out that many y's. Be a ways, I don't really mind. It just takes seconds really, but you know, like use up the board space. You know, what if I had y to the 198th? Okay. Well, what I want to say is I can group this in 4s with 1 left over. Okay. Actually, it's not what I want to do. I want to make 4 groups of x's. Okay, so now I've got a 4th power, whatever's in the parentheses here, right? Got a 4th power of this thing, which is just x squared, right? So that's x squared to the 4th times x. Okay, so I can write this as the 4th root of, well, I'm going to do something with 2 to the 7th also, but I'm going to do the x to the 9th, and I'm going to write that as x squared to the 4th. I'm going to put my x out here in the end. Give myself a little more room in case I've got other stuff, right? Okay. So now I've got my x to the 9th in there. Left myself room to do other stuff. Okay, well, I've got 3. I've only got 1 3. I'm not going to be able to take a 4th root of that. I'm not going to be able to get rid of any of those 3s. I don't get rid of them, but I'm not going to be able to regroup the 3s because there's only 1 of them. It's a group of 1. I can't get 4 of anything into a single 3. Okay, but what about 2 to the 7th? Well, I'll write that out this way. Okay. Now let's see, what can I do? Can I get 4 of anything in there? Well, yeah. Right here, I've got 2 to the 4th. Here I've got 2 cubed. I do a fourth root of 2 to the 4th. Okay, so that's 2 to the 4th times 2 cubed. Okay, well, I'm going to write it up here. I'm going to do 3 times 2 to the 4th times 2 cubed. So now I've got a 2 to the 4th and the next square to the 4th, and I can do a fourth root of it. That means the 2 is going to come out of here, and the next square is going to come out of here. Well, then what am I going to do with y to the 19th? Well, how many of these can I group in 4s? I've got 19 of them. Okay. If I've got 19 y's written out here, can I do 4 groups of 3? 4 groups of 3 would be how many of them? 12, right? Do 4 groups of 3. Okay, can I do 4 groups of 4 y's? Yeah, that'd take up 16 of them. Well, I can make myself a note then that y to the 19th equals y to the 4th to the 4th power. That's going to use up 16 of them, right? I've got 4 of them, and I've got 4 of those groups. I've got 16. And that's times y cubed. Okay. Now, a shorter way of doing that, once you understand the grouping, and you really want to understand it by grouping, because when you do any of this, you want to visualize the groups. Okay. But the question then is, well, how many 4s are there in 19? There are 4 4s in 19 with 3 left over, right? There's a remainder of 3. So really all I've got to do is divide this by 4 and see what the remainder is, and I know how it's going to group. But I will have to see that connection. Otherwise, if I just remember, oh, you divide this by this and take what's left over and do what you do, you forget why you're doing it. And then you get to where you need it and you haven't done it in a while and you can't figure it out. If you see the grouping, if you understand it at the level of grouping, then you understand it and you can reason it out. Now, best thing is memorize the rule and visualize the grouping. Use the rule, but visualize the grouping, because if you do that, you can both use the rule, which is quick and easy, but you also understand why it works. Okay, so what you have then is y to the 4th to the 4th times y cubed. Now I've got all the, I don't have any one of the factors with a power greater than 4. Every factor or every group has close to 4 on it, okay? And I have all the stuff that's left over. And now I'm going to write that out. I'm going to change the order. I'm going to put the 3 out in front. I'm going to do the 2 to the x squared and the y to the 4th all in a group to the 4th power. Times xy cubed. Now I'm going to write this as fourth root of 2x squared y to the fourth times the fourth root of 3xy cubed. The fourth root of the fourth power is just whatever's in there, and that's just 2x squared y to the fourth. This doesn't simplify anymore. There's 3xy cubed. Anyway. Okay. So we have this, and of course, somebody just called me on it. I wasn't careful. I didn't write out the 2 cubed. Okay, so what happened to 2 cubed? Oh, didn't write it in there. So I'm going to have to fix that. Okay, you do want to be careful. You do everything. I was so enthusiastic about getting to the end of this thing, but I just left it off. Okay, so that's 2 cubed times x y cubed. So now I have 3 times 2 cubed. Times xy cubed. And I'm going to write it out here, 3 times 2 cubed times xy cubed. Because now I can go back and just make sure everything agrees. Okay? Now it's like if I take this, I've got something to the fourth. If I'm taking the fourth root of something to the fourth power, then just that something comes out. The fourth power goes away because you're taking the fourth root of it. So it's here. If I wanted to put it back in, I'd have to do a fourth power of this, right? Now, if I did a fourth power of this, I'd have 2 to the fourth, right? So if I want to put this back in here, I'd have to put a 2 to the fourth back in here. With the 2 cubed, that is going to give me my 2 to the 7th. Now, see, I'd have caught that mistake in the last step here. Okay. Because I'm checking, and you always got to check. Okay. If I want to take that x squared back in here, it's got to become an x to the 8th. Okay. And if I do an x to the 8th with an x, I do get an x to the 9th, so that checks out. I want to put this y to the 4th back in, it's got to be a y to the 16th. And a y to the 16th times a y to the 3rd is going to give me my y to the 19th. So everything checks out and the 3 is still there. Okay. So if I check this against this, with that insight, everything works out. Now, if you understand that, that's a pretty good chunk. And if you don't, well, you could go back and see what open math is telling you. They're telling you the same thing. But you're going to be more likely to recognize it since you've had your hands on it and worked through it, since you spent a couple of days on it. Okay. So that's kind of a full circle. Okay, so you want to solve this equation, meaning find value or values of x make it so. And well, first suggestion I had was let's let x equal 0. So let's say, how about x equals 0? Right. 0 minus 3 times 0 plus 2. Is this equal 0? Well, that's negative 3 times 2 equals 0. And the answer, nope. Didn't work. Ever try it? Everybody wants to do that. I mean, 90% of the people, the first time they see that, want to use 0. Oh, 0 gives you 0. Well, not if you plug it in here, it doesn't. So thank you for the suggestion, and you followed it up with the right answer, okay? With two right answers, okay. So we've got aha. Y(x) equals 3. Well, let's see if that works. 3 minus 3 times 3 plus 2. Does that equal 0? Well, that's 0 times 5. 0 times 5 equals 0. Yep. Okay, so there's a solution. You don't always do this by trial and error. There's a more formal way that we do it, but we want to first see this. We're using what's called the zero property of multiplication. If you multiply something by 0, it's 0. Okay, you're going to get 0. No matter how many things you multiply, if one of them's 0, the whole blame thing is 0. Okay. Also, x equals -2 because 3 minus -2 times -2 plus 2. That equals 0. Well, this is 5 times 0 equals 0. Yep. Okay. Okay. So that's easy. Well, that means if I have this equation, what do you want to do when you see x squared plus 5x plus 6? Well, hopefully you want to factor. Okay. So if you've got an expression like this and you can factor, you're going to get x plus 3, in this case, times x plus 2 equals 0. Now, a little more formally, I'm going to say, okay, this is true if this is 0, it's true if this is 0. So that means you say x plus 3 equals 0, or x plus 2 equals 0. I wrote a 0, but it looked like a 2. Okay, makes sense? Okay, well, now if x plus 3 equals 0, you can use your algebra, which is totally okay. Subtract 3 from both sides, right? Then you get x equals -3. Now, in this case, you could have just looked at that. Okay. But if something factors down to like 17x plus 384 times 15x plus 91, okay, you're probably going to want to do the algebra because you're going to have a number in front of the x. You just don't convert it. If you just got a plain x with a number, then you can immediately see what it is. It's not always true. I mean, it's not always the case. You don't always have. And you do the same thing here, and you get x equals -2. Again, these steps would be unnecessary here, but if you have more complicated factors, then it's not as true. Okay. It's not as, but it's still easy. It's still, if you got linear factors, it's got linear functions. A linear equation, you know how to solve linear equations. So you can always solve. Okay. Okay, well, what if you have x squared plus 5x plus 5 equals 0? Well, I'll give you a hint. You're out of luck. You can't factor that. you're going to use the quadratic formula. Everybody remember the quadratic formula, right? Okay, you don't feel bad. I went to a very selective school. They didn't teach anything below calculus. It was a tough calculus course. And every freshman took it if they hadn't already passed it. Advanced placement exam or something. Okay, some did. But most of us got into that calculus. And I got in, I had pretty high SAT scores. So I got into a class with a real professor, not a grad student. So it's, probably upper third in a selective school. I wasn't in the upper 10% by any means. Really smart people there. But probably upper third. Okay. And I was shocked. Fewer than half the people remembered the quadratic formula. I mean, from age 14 on, I was incapable of forgetting the quadratic formula because I used it a lot. I don't know where these other people came from, but they were in a tough class. They apparently had good SAT scores and had top high school grades and all that stuff. I didn't have top high school grades. I like to play football, baseball, and basketball. I was a little selective about what I made A's in, what I made B's in. Usually it was A's and B's. And in math and physics, it was A's. So, they let me in the door. Okay, so anyhow, that's neither here nor there. All I'm saying is a lot of future engineers came to college not knowing the quadratic formula, even though they'd had algebra 2 and a more advanced math course. They didn't let you in the door. They had through equivalent analysis course. Okay. Well, that prelude, I'm going to write down the quadratic formula for you. I'm going to write down not just the formula, but what it means. Okay, this deserves a prominent comment. Okay, here. It's very prominent. Am I still on the board? Yeah, I've got all the way to here. Okay. Okay. Now that's just a formula. You identify A, B, and C, and you plug the numbers in, and you just do the arithmetic. It's no big deal. Now, look, what are A, B, and C? A is the number in front of X squared. So what would A be for this? What's in front of X squared? Nothing, so it's 1. There's no 0 there. Just because there's nothing there doesn't mean it's 0, right? Because with 0, you wouldn't even have the X squared, because 0 times X squared just give you 0, you wouldn't have to include it. It's a 1x squared, okay? So if there's no number in front of an X or an X squared or an X cubed or whatever, there's a 1. It's understood. Okay, so A is 1. Did you put a 1 in here and a 1 in here? I'll bet you could. Okay, you're going to write this thing down using the values of A, B, and C. And the 1 is going to go here, is going to go here. Okay, well, what's in front of X? 5, right? Which letter is that going to be? That's B, right? B is what's in front of X. That's going to be 5. So you're going to replace your B's by 5. And what's C? It's the number that doesn't have an X in front of it, X next to it. That's going to be 6. So you're going to put 6 in for C. It only occurs once. And now you've got numbers here, and you just do what the numbers say. Fair enough? Okay, well, let's see. Okay, now I'm going to complete the statement. It's true for these values and only for these values. Okay. So I'm going to ask you to go ahead and write this expression out with the A, B, and C that we get here. And we're going to work it out. I'm going to let you work it out. And if you work it out correctly, you're going to end up with these two numbers. Okay. So go ahead and see if you can do the substitution. Okay. So here we go. Okay. We've seen that A is 1, this A is the number in front of x squared. B is 5, is the number in front of x. C is 6. I'll write out the logic of it. This is 0 if and only if x equals -5 plus or minus square root of 5 squared minus 4 times 1 times 6, all divided by 2. Okay, you want to write it all out. But that equals -5 plus or minus square root of 1. All that over 2. Okay. So just right, yeah, the only difference I have here is I evaluated this. You both got the 1. Okay. So everybody got that. And of course, the square root of 1 is what? Show me. It's 1. Yeah. And of course, we know that. So we have -5 plus or minus 1 over 2. Now that's plus or minus. And I haven't explained that. Okay. It's plus or minus. That means it's the plus in this case, or it's the minus. Now, what do you get? What's -5 plus 1 over 2? Show me with your fingers. Yeah, thanks. Okay. All right. Okay. And what's -5 minus 1 over 2? -3. Okay. So the arithmetic is simple. Okay, now I'm going to quickly work out this one and this one. I know that you can do the substitution, and I know that you can do the arithmetic. It could slip out of my head. Okay, how about x squared plus 5? 5x plus 5. Well, you get A is 1, B is 5, C is 5. You get x equals -5 plus or minus the square root of 25 minus, now your 4x is going to be 20. I skipped a step there, but that's what you're going to get if you do the arithmetic, assuming I did it right. There it is. Those are your two answers. Okay. And you can't do anything with square root of 5. You can't factor it. So you can't group anything and pull it out of the square root. Sometimes you can, often you can. got a, you know, got a factor of 4 in there, you pull out 2. Just along the lines of what we've been doing, okay? Now, what if I have x squared plus 5x plus 7 equals 0? Well, let's just write out this and take just the same as before. Okay. You can see what's 4 times 7? It's 28. 45 minus 28 is -3. So we get 5, -5 plus or minus the square root of -3 over 2. Uh-oh. What's the square root of -3? Not a real number, because any real number you multiply by itself is going to give you a positive. If you multiply 2 negatives, you get a positive. Multiply 2 positives, you get a positive. So no real number has a square that's equal to -3. Well, fortunately, we can extend our concept of number to what we call complex numbers. Now, you don't understand what I do here, except you might not understand why I do it. Okay. Well, I'm going to cheat. I'm going to say, okay, we got -5 plus or minus the square root of 3 times -1. I can simply do that, right? And what we saw earlier, it's pretty clear that I could then write that as -5 plus or minus the square root of 3 times the square root of -1 over 2. Okay. Let's give the square root of -1 a number, small I. Stands for imaginary. It's an imaginary number. Okay, now, if you guys are looking to do, you're probably never going to get into the differential equations course and quantum mechanics or any of the stuff. Well, this thing really kind of becomes real. Okay, but I can tell you, we would not have our technological civilization without this. There are equations we wouldn't be able to solve if we didn't have this convention or something equivalent to it. And in some cases, like in quantum mechanics, into the Pauli season, you don't know what those are, and there's no reason you want to. But you'd have to study a whole lot of mathematics and physics to get there. But turns out they're inevitable if you want to explain the universe. Okay. So anyhow, we write that then as -5 plus or minus square root of 3 times pi over 2. And of course, we could then use the distributive law, write that as -5 halves plus or minus the square root of 3 over 2 times I. Okay. So this thing has a solution no matter what numbers you put in. Sometimes it's real, sometimes it's complex. This is complex. There's a real number and a complex number. Okay. Square root of 3 over 2 times I is a complex number. -5 halves is as real as you can get. You have -$2.50. You know, just lose $2.50. You're -5 halves. That's pretty real. Okay. Probably survive losing $2.50. But you don't want it. Okay, does that make sense? And you really don't have imaginary money. Although you Monopoly, I guess that's kind of imaginary. It's a different thing. Okay. There it is. So have a ball with it. I'll take a look at I did include in the assignment how you do arithmetic with complex numbers. I'm probably going to leave that assignment there and see what you can do here. Okay. Arithmetic is really easy. until you get to division. That's a little tricky. So I think you probably can do most of that assignment. And I think open math will explain it well because it just comes down to the distributive law. And simplifying similar terms.